Role of Enterprise System Administrator. Hello everyone. Welcome to my channel. In this video, we are going to explore the real-world responsibilities of an enterprise system administrator. Not just theory, but what actually happens in production environments. If you are preparing for system administrator roles, L2, L3, or even aiming for cloud and hybrid infrastructure roles, this video will give you a complete understanding. We will cover key areas like Active Directory, Windows Server Administration, DNS and DHCP, Azure Cloud, Microsoft 365, virtualization, and also troubleshooting and real-time incident handling. But this is not just about responsibilities. I will also show you the actual tools used in the industry to perform these tasks. Because in real environments, it's not about knowing definitions. It's about knowing which tool to use, when to use it, and how to fix issues quickly. So let's get started with Active Directory Management, the backbone of any enterprise environment. Active Directory Management. Now let's talk about Active Directory Management, which is one of the most critical responsibilities of a system administrator. In any enterprise environment, Active Directory is used to manage users, computers, groups, and security policies. As an administrator, you will be responsible for managing components like Active Directory domain services, sites and services, trust relationships between domains, and sometimes even schema updates. To perform these tasks, we use several important tools. The most commonly used tool is Active Directory Users and Computers, also known as ADUC. This is where you create users, reset passwords, manage groups, and handle daily operations. Next, we have Active Directory Sites and Services. This tool is very important for managing replication between domain controllers, especially in multi-location environments. Then we use Active Directory Domains and Trusts to configure trust relationships between different domains or forests. For advanced troubleshooting and deep-level changes, tools like ADSI Edit and LDP are used. But these should be handled carefully, because incorrect changes can impact the entire directory. So in short, Active Directory Management is not just about creating users. It's about managing the entire identity infrastructure of an organization. AD Troubleshooting and Replication. Now let's move to one of the most important and challenging areas, Active Directory Troubleshooting. In real-time environments, issues like replication failures, authentication problems, and Kerberos errors are very common. For example, users may report that they are unable to log in, or group policies are not applying, or domain controllers are not syncing properly. To troubleshoot these issues, we use powerful command line tools. One of the most important tools is repadmin. This helps us check replication status between domain controllers. Then we use DCDIAG, which performs a complete health check of domain controllers and identifies issues. Another useful tool is NLTest, which helps verify domain trust relationships and secure channels. For Kerberos-related issues, we use CLIST to check and manage tickets. Along with these, Event Viewer plays a major role. Most of the time, the root cause of the issue can be found in system and security logs. In some advanced cases, we also use Wireshark to analyze network traffic and identify authentication failures. So troubleshooting Active Directory is all about using the right tools, analyzing logs, and understanding how different components interact with each other. Security and hardening. Now let's talk about one of the most critical responsibilities of a system administrator, security and hardening. In today's environment, managing servers is not enough. We also need to make sure that systems are secure from internal and external threats. One of the primary ways we implement security in an enterprise environment is through group policy. Using group policy, we can enforce rules like password policies, account lockout settings, restricting access to control panel, disabling USB devices, and many more security configurations across all systems. For managing these policies, we use the Group Policy Management Console. Now in real time, one common issue is weak security configurations. For example, if password policies are not properly configured, users may create simple passwords, which becomes a major risk. To solve this, organizations follow standard security baselines. This is where the Microsoft Security Compliance Toolkit comes into the picture. It provides predefined security settings based on industry best practices, which we can apply to our environment. Another important area is endpoint security. We use tools like Windows Defender or Microsoft Defender for endpoint to monitor threats, detect malware, and respond to security incidents. For example, if a suspicious file is detected on a server, Defender can automatically quarantine it and alert the administrator. In addition to this, we also perform vulnerability scanning. Tools like Nessus or Qualys are used to scan servers and identify security gaps, missing patches, or misconfigurations. In real time, I have seen cases where server was missing critical updates, and vulnerability tools highlighted it as a high-risk issue. After identifying the issue, we apply patches and fix the vulnerability to secure the system. So overall, security and hardening is not a one-time task. It's a continuous process of monitoring, fixing, and improving the system security posture. And as a system administrator, this responsibility is extremely important, because even a small misconfiguration can lead to major security incidents. Domain controller upgrades and AD migration. Now let's move to a very critical and high-responsibility task in enterprise environments: domain controller upgrades and Active Directory migration. This is not a daily activity, but whenever it happens, it directly impacts the entire organization. So it must be handled very carefully with proper planning and execution. Let's first understand what this means. A domain controller upgrade usually happens when an organization wants to move from an older Windows Server version, like 2012 or 2016, to a newer version such as 2019 or 2022. Similarly, Active Directory migration is required when there are changes like domain restructuring, mergers, acquisitions, or moving to a new forest. Now in real time, this is not just a simple upgrade process. If something goes wrong, users may not be able to log in, applications may fail, and authentication services can completely stop. So before performing any upgrade or migration, the first and most important step is planning. We start by checking the health of the existing environment. We use tools like DCDIAG and repadmin to make sure all domain controllers are healthy and replication is working properly. If there are existing issues, we must fix them first before proceeding. Next step is backup. We always take a full system state backup of domain controllers. For this, we use Windows Server Backup or enterprise tools like Veeam. This is very important because if anything fails during migration, we should be able to restore the environment quickly. Now coming to the tools used in migration. One of the key tools is the Active Directory Migration Tool, also known as ADMT. This tool helps us migrate users, groups, and computers from one domain to another without losing their passwords or SID history. This is very useful in scenarios like company mergers, where we need to move users from one domain to another. Another important component is DFS replication. DFS is used to replicate data between servers, especially for things like SysVol, which is critical for group policy. During domain controller upgrades, SysVol replication must be healthy, otherwise group policies may not work properly. Now let's talk about the actual upgrade process. We install a new server with the latest Windows Server version. Then we promote it as a domain controller using Windows Server Setup and Active Directory Domain Services installation. Once the new domain controller is added, it starts replicating data from existing controllers. After that, we transfer FSMO roles from the old server to the new one. These roles are very important because they control key operations in Active Directory. Once everything is verified and stable, we can safely decommission the old domain controller. In real time, one common issue during migration is replication delay or failure. For example, a user created on one domain controller may not appear on another. In such cases, we use repadmin to force replication and check for errors. Another issue can be DNS misconfiguration, which can cause authentication failures. So DNS must always be properly configured before and after migration. Finally, after completing the upgrade or migration, we perform validation. We check user login, group policy application, replication status, and overall system health. So to summarize, domain controller upgrades and AD migration require proper planning, health checks, reliable backups, correct use of tools like ADMT and DFS, and careful execution. Because even a small mistake can impact the entire organization. That's why this task is usually handled by experienced administrators and is considered a critical responsibility in enterprise environments. Monitoring and health checks. Now let's talk about monitoring and health checks, which is one of the most critical responsibilities of a system administrator. In any enterprise environment, systems are running 24/7. So we cannot wait for users to report issues. We need to proactively monitor systems and identify problems before they impact the business. This is where monitoring and health checks come into the picture. One of the key areas we monitor is Active Directory health. Because Active Directory is the backbone of authentication. If AD is down or unhealthy, users cannot log in, applications may fail, and business operations can stop. So regularly, we perform health checks to ensure that domain controllers are working properly. Replication is happening without issues. And all services are running as expected. Now in real time, one of the most common issues is replication failure. For example, changes made on one domain controller are not reflecting on another. This can lead to login issues or outdated group policies. To identify such problems, we use monitoring tools and logs. One of the most important tools is Performance Monitor, also known as PerfMon. Using PerfMon, we can track system performance metrics like CPU usage, memory consumption, disk activity, and network performance. For example, if a server is slow, we can use PerfMon to identify whether the issue is due to high CPU usage, memory pressure, or disk bottlenecks. Another powerful tool is Event Viewer. Event Viewer provides detailed logs about everything happening in the system. In real-time troubleshooting, this is usually the first place we check. For example, if a service fails or a login issue occurs, we can go to system logs or security logs and identify the exact error message. Now, along with manual tools, automation also plays a big role. We use PowerShell scripts to perform regular health checks, generate reports, and even automate issue detection. For example, a PowerShell script can be scheduled to check replication status daily and send an alert if any failures are detected. In enterprise environments, we don't rely only on manual checks. We use centralized monitoring tools like SolarWinds, Nagios, or PRTG. These tools continuously monitor servers, services, network devices, and applications. They provide real-time alerts when something goes wrong. For example, if a server CPU usage crosses a threshold, or if a service stops. These tools immediately send alerts via email or dashboards. This helps administrators take action before users even notice the issue. Now, in modern hybrid environments, cloud monitoring is also very important. We use Azure Monitor to track performance and health of Azure resources and even on-prem servers connected to Azure. Azure Monitor provides insights, alerts, and dashboards, which help in identifying trends and preventing future issues. Now let's talk about root cause analysis, also known as RCA. Fixing an issue is not enough. We need to understand why it happened. For example, if a server goes down due to high CPU usage, we need to analyze what caused the spike. Was it a background process? Was it a patch? Was it a memory leak? This analysis is called RCA. In real time, after every major incident, we perform RCA and document the findings. This helps prevent the same issue from happening again in the future. So overall, monitoring and health checks are not just about tools. It's about being proactive, analyzing system behavior, and preventing issues before they become critical. And this is what differentiates a normal administrator from a highly skilled system engineer. Now let's talk about Windows Server administration, which is one of the core responsibilities of a system administrator. In any organization, servers are responsible for running critical applications, handling user authentication, managing data, and supporting business operations. So as a system administrator, our job is to ensure that these servers are always stable, available, and performing efficiently. Now in real time, we deal with different types of issues like operating system errors, unexpected server crashes, performance bottlenecks, and service failures. Let's start with performance issues. One of the most common problems in production environments is server slowness. Users may report that applications are slow, login is taking time, or systems are not responding properly. In such cases, the first tool we usually check is Task Manager. Task Manager gives a quick overview of CPU usage, memory consumption, disk activity, and running processes. For example, if CPU usage is constantly high, we can identify which process is consuming the most resources. But Task Manager gives only a basic view. For deeper analysis, we use Resource Monitor. Resource Monitor provides detailed insights into CPU, memory, disk, and network usage. For example, if a server is slow due to disk issues, we can identify which process is causing high disk I/O and take action accordingly. Now let's move to another important area: Event Viewer. Event Viewer is one of the most powerful tools for troubleshooting. Whenever something goes wrong in the system, whether it's a service failure, login issue, or system crash, it gets recorded in Event Viewer logs. In real time, this is usually the first place we check to identify the root cause. For example, if a service is not starting, Event Viewer will show the exact error message, which helps us quickly understand the problem. Next, we have msconfig. msconfig is used to manage startup services and boot configurations. In troubleshooting scenarios, we use it to disable unnecessary startup services, perform clean boot, and identify if any third-party service is causing issues. Now another very important tool is Services Console, also known as Services.Master of Science. Many applications depend on background services to run properly. If a service stops or fails, the application will not work. So using Services.Master of Science, we can start, stop, restart, and configure services. For example, if a web server service is down, we can restart it and restore the application quickly. Now let's move to advanced troubleshooting, system crashes. In some critical situations, servers may crash or show blue screen errors. In such cases, basic tools are not enough. We need to analyze memory dump files to understand what caused the crash. For this, we use a tool called WinDBG. WinDBG helps us analyze dump files and identify the root cause, such as driver issues, hardware failures, or kernel-level problems. In real time, this is usually handled by experienced administrators, because it requires deeper technical knowledge. Now let's look at a real-time scenario. Suppose a production server suddenly becomes very slow. Users start reporting application delays. First, we check Task Manager and notice high CPU usage. Then we open Resource Monitor and identify a specific process consuming resources. Next, we verify logs in Event Viewer to see if any errors are related. If needed, we restart the service using Services.Master of Science. And finally, we monitor the system to ensure stability. This step-by-step approach helps us quickly identify and resolve issues. So overall, Windows Server Administration is not just about managing servers. It's about monitoring performance, troubleshooting issues, analyzing logs, and ensuring that systems run smoothly without impacting users. And this is what makes a system administrator a critical part of any organization's IT infrastructure. Now let's move to one of the most important and practical areas in system administration: performance troubleshooting. In real-time environments, performance issues are very common. Users may report that applications are slow, servers are not responding, or systems are taking too much time to process requests. As a system administrator, our responsibility is to quickly identify the root cause and resolve the issue without impacting business operations. Now, performance issues are mainly related to 4 key areas: CPU, memory, disk, and network. Let's start with CPU. If CPU usage is high, The server may become slow or unresponsive. In such cases, the first tool we check is Task Manager. Task Manager gives a quick overview of CPU utilization and shows which processes are consuming resources. If we need deeper analysis, we use Resource Monitor. This helps us understand how CPU is being used across different processes and services. Now let's talk about memory. If memory usage is high, applications may become slow or even crash. In Task Manager, we can check memory consumption. But in Resource Monitor, we get more detailed insights like used memory, standby memory, and free memory. This helps us identify if there is a memory leak or excessive usage by a specific process. Now moving to disk performance. Disk issues are one of the most common causes of server slowness. If disk I/O is high, applications may take longer to read or write data. Using Resource Monitor, we can identify which process is generating high disk activity. We can also check disk queue length to understand if the disk is overloaded. Now let's talk about network performance. Sometimes the issue is not with CPU or memory, but with network connectivity. Users may face delays while accessing applications or servers. In such cases, we use basic but very powerful command line tools. For example, ping is used to check connectivity between systems. If ping fails, it indicates a network issue. Next, we use traceit to trace the path between source and destination and identify where the delay is happening. Another important tool is netstat. Netstat helps us check active network connections, listening ports, and network statistics. This is very useful in identifying suspicious connections or port-related issues. Now let's move to one of the most powerful advanced tools, Process Explorer from sysinternals. Process Explorer is like an advanced version of Task Manager. It provides detailed information about processes, including CPU usage, memory usage, handles, and dependencies. In real time, this tool is very useful when we are unable to identify the issue using basic tools. For example, if a process is consuming high CPU but not clearly visible in Task Manager, Process Explorer can help us drill down and identify the exact cause. Now let's look at a real-time scenario. Suppose users report that an application hosted on a server is very slow. First, we open Task Manager and check CPU and memory usage. If CPU is high, we identify the process. Next, we open Resource Monitor to analyze disk and memory usage. If everything looks normal, we move to network troubleshooting using ping and traceit. If still the issue is not clear, we use Process Explorer to analyze processes in detail. Finally, once we identify the root cause, we take corrective action like restarting a service, optimizing resources, or fixing network issues. So performance troubleshooting is not just about tools. It's about following a structured approach, analyzing system behavior, and identifying the exact root cause. And this skill is what differentiates a basic administrator from an advanced system engineer. Because in real time, quick and accurate troubleshooting is the key to maintaining system stability and user satisfaction. Now let's talk about DNS and DHCP management, which are two of the most critical services in any enterprise environment. In simple terms, DNS is responsible for name resolution, and DHCP is responsible for IP address assignment. Without these two services, systems cannot communicate properly, and users will not be able to access applications, servers, or even the internet. Let's start with DNS. DNS, or Domain Name System, translates human-friendly names like server names into IP addresses. For example, when a user tries to access a server using its name, DNS converts that name into an IP address so the system can connect. As a system administrator, we manage DNS zones, which contain records like A records, CNAME records, MX records, and so on. We also ensure proper replication of DNS data, especially in Active Directory integrated environments. The primary tool used for managing DNS is DNS Manager. Using DNS Manager, we can create, modify, and delete DNS records, manage zones, and troubleshoot name resolution issues. Now in real time, one of the most common issues is DNS resolution failure. For example, a user may say that they are unable to access a server using its name, but they can access it using the IP address. This clearly indicates a DNS issue. In such cases, we use tools like nslookup to verify whether the DNS record is resolving correctly. We also use ipconfig commands like ipconfig flushdns to clear the local DNS cache, and ipconfig registerdns to re-register DNS records. Another important tool is DNSCMD, which is a command line tool used for advanced DNS management and automation. Now let's move to DHCP. DHCP, or Dynamic Host Configuration Protocol, automatically assigns IP addresses to devices in the network. This eliminates the need for manual IP configuration and reduces errors. As administrators, we manage DHCP scopes, which define the range of IP addresses available for assignment. We also configure reservations, so specific devices always get the same IP address. The main tool used here is DHCP Manager. Using DHCP Manager, we can create scopes, monitor IP usage, configure options like default gateway and DNS servers, and troubleshoot issues. In real time, a common issue is IP address conflict or IP exhaustion. For example, if all IP addresses in a scope are used, new devices will not get an IP address. In such cases, we need to extend the scope or free up unused IPs. Another issue can be incorrect DHCP configuration, which may assign wrong DNS servers, leading to name resolution problems. Now automation and scripting also play an important role. We use PowerShell for managing both DNS and DHCP. For example, we can create DNS records, check DHCP leases, and generate reports using PowerShell scripts. This is very useful in large environments where manual management is not practical. Now let's look at a real-time scenario. Suppose a user reports that they are unable to access an application. First, we check connectivity using ping. If ping fails with a name but works with IP, we know it is a DNS issue. Then we use nslookup to verify DNS resolution. If needed, we check DNS Manager and fix the record. If the issue is related to IP assignment, we check DHCP Manager to see if the device has received an IP address. If not, we verify the scope and lease availability. This step-by-step approach helps us quickly identify and resolve the issue. So overall, DNS and DHCP are the foundation of network communication. And as a system administrator, we must ensure that these services are always available, properly configured, and running without issues. Because even a small problem in DNS or DHCP can impact the entire organization. Now let's move to one of the most important and trending areas in system administration, Azure and hybrid infrastructure. Today, most organizations are not fully on-premises and not fully in the cloud. They operate in a hybrid model, where some resources are hosted on-premises and others are running in the cloud. As a system administrator, it is very important to understand how to manage and integrate both environments smoothly. Let's start with Azure Virtual Machines. Azure VMs are cloud-based servers that we use to host applications, services, and workloads. Just like physical or on-prem servers, we are responsible for provisioning, configuring, monitoring, and maintaining these virtual machines. We can create and manage these resources using the Azure portal, which is a web-based interface. It is very user-friendly and allows us to perform most administrative tasks like creating VMs, configuring storage, setting up networking, and managing access. Now in large environments, manual work is not enough. This is where automation tools come into the picture. Azure CLI and Azure PowerShell are command line tools that allow us to automate tasks. For example, instead of manually creating multiple virtual machines, we can use scripts to deploy them quickly and consistently. This saves time and reduces human errors. Now let's talk about networking in Azure. Networking is a critical component in hybrid environments. We use virtual networks, also known as VNets, to create isolated networks in Azure. Within these VNets, we configure subnets, network security groups, also known as NSGs, and sometimes VNet peering to connect different networks. In real time, one common issue is connectivity failure between on-premises and Azure resources. This can happen due to incorrect NSG rules, routing issues, or VPN misconfiguration. So understanding Azure networking is very important for troubleshooting. Now let's move to Identity and Access Management, also known as IAM. IAM is responsible for controlling who can access what resources. In Azure, we use role-based access control, also known as RBAC, to assign permissions to users, groups, or services. For example, we can give a user read-only access, or full administrative access depending on their role. This ensures security and proper access control in the environment. Now, one of the most important components in hybrid infrastructure is Azure AD Connect. Azure AD Connect is used to synchronize on-premises Active Directory with Azure Active Directory. This means users created in on-prem AD are automatically synced to Azure, allowing them to access cloud services like Microsoft 365. In real time, if synchronization fails, users may not be able to log in to cloud applications. So we need to monitor and troubleshoot Azure AD Connect regularly. Now let's talk about monitoring. Just like on-prem environments, monitoring in Azure is very important. We use Azure Monitor to track performance, health, and activity of resources. Azure Monitor provides alerts, logs, and dashboards, which help us identify issues quickly. For example, if a virtual machine CPU usage is high, Azure Monitor can trigger an alert, allowing us to take action immediately. Now let's look at a real-time scenario. Suppose a user reports that they are unable to access an application hosted in Azure. First, we check if the virtual machine is running using Azure Portal. Next, we verify network connectivity and NSG rules. If the issue is related to login, we check Azure AD and Azure AD Connect synchronization. We also review logs in Azure Monitor to identify any errors. This structured approach helps us quickly identify and resolve issues. So overall, Azure and hybrid infrastructure is about integrating on-prem and cloud environments, managing resources efficiently, ensuring secure access, and continuously monitoring the system. And in today's IT world, this skill is highly valuable and in high demand. Now let's talk about Microsoft 365 administration, which is one of the most commonly used platforms in modern organizations. Today, almost every company uses Microsoft 365 for email communication, collaboration, file sharing, and productivity. As a system administrator, managing Microsoft 365 services is a critical responsibility. This includes user management, Exchange Online administration, SharePoint management, licensing, and security. Let's start with user management. In real-time environments, we regularly create new users, modify existing users, assign licenses, and deactivate accounts when employees leave the organization. For this, we use the Microsoft 365 Admin Center. This is the central portal where we manage users, assign licenses, reset passwords, and monitor service health. Now, one of the most important services in Microsoft 365 is Exchange Online. Exchange Online is used for email communication. As administrators, we manage mailboxes, distribution groups, shared mailboxes, and mail flow rules. For example, if a user reports that emails are not being delivered, we need to troubleshoot mail flow. For this, we use the Exchange Admin Center. Here we can track messages, check mail flow rules, and identify if emails are blocked, delayed, or redirected. In real time, one common issue is email delivery failure. For example, emails may go to spam, or users may not receive emails due to incorrect configurations. In such cases, we analyze message trace logs and fix the issue. Now let's talk about SharePoint Online. SharePoint is used for document management and collaboration. Users can store files, share documents, and work together in teams. As administrators, we manage site collections, permissions, and storage. In real time, one common issue is access problems. For example, a user may not be able to access a SharePoint site. In such cases, we verify permissions and ensure the user has the correct access rights. Now let's move to PowerShell. While portals are useful, in large environments, automation is very important. We use PowerShell for advanced administration tasks. For example, we can bulk create users, assign licenses, manage mailboxes, and generate reports using PowerShell. Modules like Exchange Online PowerShell and MSOL are commonly used. This helps save time and ensures consistency. Now let's talk about security. Security is a major concern in Microsoft 365 environments. We use the Security and Compliance Center to manage security policies, audit logs, and compliance settings. For example, we can configure data loss prevention policies, enable multi-factor authentication, and monitor suspicious activities. In real time, if a user account is compromised, we can quickly block sign-in, reset the password, and investigate audit logs to understand what happened. Now let's look at a real-time scenario. Suppose a user reports that they are unable to send or receive emails. First, we check the user account in Microsoft 365 Admin Center to verify license and account status. Next, we go to Exchange Admin Center and perform a message trace to check email flow. If needed, we verify mailbox settings and spam filters. If the issue is related to access, we check permissions. If it's a larger issue, we use PowerShell to gather more details. This structured approach helps us quickly identify and resolve issues. So overall, Microsoft 365 administration is about managing users, ensuring smooth communication, handling collaboration tools, and maintaining security. And in today's cloud-driven world, this is one of the most essential skills for any system administrator. Now let's talk about virtualization using Hyper-V, which is a very important part of modern data center environments. In today's organizations, instead of running applications on physical servers, we use virtualization to run multiple virtual machines on a single physical server. This helps in better resource utilization, cost savings, and easier management. As a system administrator, we are responsible for managing virtual machines, ensuring high availability, and maintaining performance. Let's start with virtual machine management. A virtual machine, or VM, is like a complete computer running inside another system. We create, configure, start, stop, and manage these virtual machines based on business requirements. For managing VMs, we use Hyper-V Manager. This is the primary tool where we can create new virtual machines, allocate CPU, memory, and storage, and monitor their performance. In real time, one common task is provisioning new VMs for applications. For example, if a new application needs a server, we create a VM, install the operating system, and configure it accordingly. Now let's talk about performance and resource allocation. Since multiple VMs run on a single host, we need to carefully allocate resources like CPU, memory, and disk. If one VM consumes too many resources, it can impact other VMs on the same host. So monitoring and balancing resources is very important. Now let's move to high availability and clustering. In enterprise environments, downtime is not acceptable. If a physical server fails, we should not lose the virtual machines running on it. This is where failover clustering comes into the picture. Using Failover Cluster Manager, we can group multiple physical servers into a cluster. If one server fails, the virtual machines automatically move to another server in the cluster. This ensures high availability and minimal downtime. In real time, this is very critical for production environments. For example, if a host server crashes, users should not even notice the downtime, because VMs are automatically migrated to another host. Now let's talk about advanced management. In large environments with many hosts and VMs, managing everything manually becomes difficult. This is where System Center Virtual Machine Manager, also known as SCVMM, is used. SCVMM provides centralized management of virtualization infrastructure. We can manage multiple Hyper-V hosts, deploy virtual machines, configure networking, and automate operations from a single console. In real time, SCVMM is very useful for managing large-scale environments efficiently. Now let's look at a real-time scenario. Suppose a virtual machine becomes very slow. First, we check its resource usage in Hyper-V Manager. If CPU or memory usage is high, we adjust resource allocation. If the issue is related to the host, we check overall host performance. If needed, we can migrate the VM to another host to balance the load. Now consider another scenario, a host server failure. In a clustered environment, Failover Cluster Manager automatically shifts the VMs to another available host. This ensures business continuity without manual intervention. So overall, virtualization using Hyper-V is about efficient resource utilization, managing virtual machines, ensuring high availability, and maintaining performance. And as a system administrator, this is a critical skill in managing modern IT infrastructure. Now let's talk about patch management, which is one of the most critical responsibilities of a system administrator. In any enterprise environment, servers and systems must be regularly updated to fix security vulnerabilities, improve performance, and maintain compliance with organizational policies. Patch management is not just about installing updates. It is a complete lifecycle that includes planning, testing, deployment, and validation. Let's start with why patching is important. In real time, many security breaches happen because systems are not updated. Attackers often target known vulnerabilities, and if patches are not applied, systems become easy targets. So regular patching helps in protecting the infrastructure from security risks. Now, as administrators, we follow a structured approach for patch management. First step is planning. We review available updates, analyze their impact, and decide which updates need to be applied. In production environments, we cannot directly apply patches without testing. So we usually test patches in a staging or test environment before deploying them to production. Next step is deployment. One of the most commonly used tools for patch management is WSUS, also known as Windows Server Update Services. WSUS allows us to centrally manage and deploy updates to multiple servers. We can approve or decline updates, schedule installations, and monitor update status. Now in larger environments, organizations use advanced tools like Patch Manager Plus. This tool provides more features like automated patch deployment, reporting, and support for third-party applications. It helps in managing patches across a wide range of systems efficiently. Now in hybrid and cloud environments, we use Azure Update Management. This tool allows us to manage updates for both on-prem and Azure-based virtual machines. We can schedule updates, track compliance, and generate reports from a centralized dashboard. Now let's talk about compliance. Many organizations have strict security and compliance requirements. They need to ensure that all systems are updated and meet security standards. Patch management tools help us generate compliance reports, which show which systems are updated and which are not. This is very important for audits and security reviews. Now let's look at a real-time scenario. Suppose a critical security vulnerability is announced. First, we identify which systems are affected. Next, we test the patch in a test environment. After successful testing, we schedule the deployment during a maintenance window to avoid business impact. We use tools like WSUS or Azure Update Management to deploy the patch. After deployment, we verify that systems are updated and running properly. If any issue occurs, we should have a rollback plan to restore the system. This is very important, because sometimes patches can cause unexpected issues. Now another real-time challenge is patch failures. Sometimes updates may fail due to insufficient disk space, service issues, or network problems. In such cases, we troubleshoot using logs and fix the issue before retrying the update. So overall, patch management is not just about applying updates. It is about maintaining system security, ensuring compliance, and minimizing risks. And as a system administrator, this responsibility is very important, because even a single missed update can lead to major security incidents. Now let's talk about incident and problem management, which is one of the most critical responsibilities in a production environment. In real time, systems can fail at any moment. Servers may go down. Applications may stop working. Users may not be able to log in. Or services may become slow. These situations are called incidents. As system administrators, our responsibility is to quickly respond to these incidents, minimize impact, and restore services as soon as possible. Now, incidents are classified based on severity. For example, if a single user is facing an issue, it is a low-priority incident. But if an entire application or service is down, it becomes a major incident. Major incidents require immediate attention, and usually involve multiple teams working together. Now let's talk about how we manage incidents. In enterprise environments, we use ticketing tools like ServiceNow or Jira. Whenever an issue is reported, a ticket is created. This ticket contains all details like issue description, priority, impacted users, and timestamps. As administrators, we work on these tickets, update the status, and ensure proper communication. Now, during major incidents, communication is very important. We use collaboration tools like Microsoft Teams or Zoom to join bridge calls. On these calls, multiple teams like network, server, application, and database teams come together to troubleshoot the issue. In real time, this is a high-pressure situation. We need to stay calm, analyze the problem, and provide updates regularly. Now, monitoring tools also play a big role. Most of the time, incidents are detected through alerts before users even report them. For example, if a server goes down, or CPU usage becomes very high, monitoring tools immediately send alerts. This helps us take action quickly and reduce downtime. Now let's talk about escalation. If an issue cannot be resolved at L1 or L2 level, it gets escalated to higher-level engineers. As L2 or L3 administrators, we handle these escalations and work on complex issues. Now let's move to problem management. Incident management is about fixing the issue quickly, but problem management is about understanding why the issue happened and preventing it in the future. This is called root cause analysis, or RCA. In real time, after a major incident, we perform RCA. For example, if a server crashed due to high memory usage, we analyze what caused the spike. Was it a faulty application? Was it a memory leak? Was it due to insufficient resources? We document the findings and take corrective actions, such as optimizing applications, increasing resources, or applying fixes. Now let's look at a real-time scenario. Suppose a production application suddenly goes down. Users start reporting issues, and monitoring tools also trigger alerts. A major incident ticket is created in ServiceNow. We immediately join a Teams call with all relevant teams. First, we check server health, application services, and network connectivity. If a service is down, we restart it. If the issue is deeper, we analyze logs and identify the root cause. Once the issue is resolved, we restore services and inform users. After that, we perform RCA and document everything. This ensures that the same issue does not happen again. So overall, incident and problem management is not just about fixing issues. It's about quick response, effective communication, team collaboration, and continuous improvement. And this is what makes a system administrator a key player in maintaining business continuity. Now let's talk about documentation and change management, which is one of the most underrated but extremely important responsibilities of a system administrator. In real-time environments, solving issues is important, but documenting them is equally critical. Because without proper documentation, knowledge stays with individuals instead of the organization. Let's start with documentation. As system administrators, we create and maintain different types of documents. This includes standard operating procedures, also known as SOPs, knowledge base articles, runbooks, and troubleshooting guides. For example, if we resolve a complex issue, we should document the steps we followed, the tools we used, and the final solution. This helps other team members handle similar issues in the future without starting from scratch. In real time, this becomes very useful during incidents. If a similar issue occurs again, we can quickly refer to the documentation and resolve it faster. Now let's talk about tools used for documentation. One of the most commonly used tools is Confluence. Confluence is used to create structured documentation, organize knowledge, and share it across teams. Another important platform is SharePoint. SharePoint is widely used in organizations to store documents, share files, and collaborate with teams. We also use tools like Notion for maintaining notes, checklists, and internal documentation. And for basic documentation, we use tools like Excel and Word. For example, Excel can be used for tracking configurations, inventories, or change logs. And Word can be used for creating detailed documents and procedures. Now let's move to change management. In enterprise environments, we cannot make changes directly in production systems. Every change must go through a proper process. This is called change management. The goal of change management is to ensure that any modification to the system is planned, tested, approved, and implemented safely. Now one of the key components of change management is CAB, which stands for Change Advisory Board. CAB is a group of stakeholders who review and approve changes before they are implemented. For example, if we want to apply a patch, upgrade a server, or modify configurations, we need to create a change request. This request includes details like what change we are making, why it is needed, what systems will be impacted, and what is the rollback plan. In real time, this process is very important, because even a small change can impact production systems. For example, a simple configuration change can bring down an application if not handled properly. So before implementing any change, we plan it carefully, test it in a non-production environment, and schedule it during a maintenance window. Now let's look at a real-time scenario. Suppose we need to upgrade a production server. First, we create a change request and document all details. Next, we present it to CAB for approval. Once approved, we schedule the activity during a maintenance window. Before starting, we take backups. Then we perform the upgrade step by step. After completion, we validate the system to ensure everything is working fine. If any issue occurs, we follow the rollback plan. Finally, we update documentation with all details of the change. This structured approach helps in minimizing risks and ensuring system stability. Now let's talk about why documentation and change management are important. They help in knowledge sharing, reduce dependency on individuals, ensure consistency, and improve efficiency. They also play a major role during audits and compliance checks. In real time, organizations expect proper documentation for every change and every major issue. So overall, documentation and change management are not just administrative tasks. They are essential practices that ensure stability, reliability, and continuous improvement in IT environments. And as a system administrator, following these processes makes you more professional, reliable, and valuable to the organization. Now with this, we have covered all the key responsibilities and tools required for an enterprise system administrator. I hope this video helped you understand real-time responsibilities and how tools are used in actual environments. If you found this useful, don't forget to like, share, and subscribe. Thank you for watching.